My name is Vick. I am the co-founder of spadeGEO, a company based in Raleigh, North Carolina. We're a technology consulting and services company really focused around geospatial solutions. Geospatial meaning data that has a locational component to it. So think plants in a field or data over time. Those are really the kind of products that we work with. I'm from Wilson, North Carolina, right here where we're located here today. It's gnat capital of the world in the middle of July, so bear with my swatting here. But, ag is a big part of what I do. I'm a product of NC State University. I graduated from bio and ag engineering. And really my passion is working with growers and folks in the ag community to really be able to use technology in an applied manner that benefits their operations. So remote sensing is a term that you might hear, but think, what is really that? But remote sensing at its core, it's measurement of information without coming into direct contact with something. And so I think about, I have a 1-year-old son, trying to wrangle him to check his temperature under his arm with a thermometer, challenging. But thankfully we have infrared thermometers that we can just point at his forehead in a matter of seconds. We can capture that information. The same is true with remote sensing. We can take sensors, be it on aircraft or drones or satellites, and measure information about a crop, everything from temperature to vigor to health, to a number of things that you can infer using remote sensing. So when we think about remote sensing in the context of agriculture, usually what we're working with is some form of aerial imagery. And there's really sort of 3 platforms that you can generally get aerial imagery from in an ag context. It could be satellite, it could be manned aircraft, or now there's a lot of applications where you can get that imagery from drones. If we think about manned and satellite imagery, those have both been around actually for a pretty good while. And there are a number of advantages, but also some disadvantages. When we think about the advantages of satellite imagery or manned imagery, they're pretty readily available, especially the satellite side. A lot of farm applications, mobile apps today are available where a farmer can, with a click of a few buttons, get aerial imagery of their crop from a satellite. The limitations are the resolution. And when I say resolution, I mean both temporally and spatially. So meaning in time and in space. A satellite might only pass over this field once every 2 weeks. And if it passes over on a day like today and there's a cloud that happens to be right over that field, I've missed it. And that window of opportunity for the satellite to pass back over may be several days away. The good news is that there are constantly more satellites going up, so the revisit frequency is increasing. There are actually some services now where you can get imagery literally every day, but there still are limitations on the resolution side. So I mentioned temporal resolution, but also spatial resolution. If we think about wanting to see at the plant level, a satellite's not going to be able to get you there. Generally, we're talking about several feet per pixel. So really it's an aggregate view that we're getting of a field versus being able to look at things at very specialized distances. When we think about drones, that's really some of the advantages that they bring to the table. It's the timely element of it, but also the spatial resolution piece. And if I want to get a drone up in the field this afternoon, say a hailstorm comes through, or I just want to check my crops, literally in a matter of minutes, I can have that drone out in the field, or a service provider can be out in the field collecting that imagery. And we're talking about pictures that are at the sub-inch level. So really, really precise imagery that one can gather from it. Now, the challenging side is there is the economy of scale. A satellite is flying over, it's collecting, let's say 40 or 50 square miles in a single shot. So you're getting a whole lot of land. The drone's going to cover maybe a few hundred acres in an hour or a single flight. So it's not feasible that I'm going to fly thousands of acres with a single drone in a single day, but there are use cases where it makes a lot of sense. So, there are a number of use cases with drones where they have been successful, or with remote sensing in general. The immediate thought that comes to mind is crop scouting, where there's going out and looking for damage across the field or looking for plant health, plant vigor. And this has been used in traditional row crops to specialty crops. Think tobacco or sweet potatoes here in North Carolina, all the way to fruit and vegetable production to permanent tree crops. There's a lot of emerging use cases, again, with all the different levels of remote sensing. And so if we think beyond the high level into some of the more targeted, more specific use cases, there are a number of examples that come to mind, some locally and again, some that are across the nation. There are farmers out there and then just ag users in general that are using drones and remote sensing for research plot assessment. So you have folks like researchers at NC State or researchers with Syngenta and Bayer that are doing these small scale plot tests across the US or across the world in a lot of cases, they're using remote sensing to actually go out and be able to, in a very repeatable and objective way, assess what's going on in those plots. If we think of another use case that might be a little bit unique, it's actually been used for damage detection on crops from things like drift. I think of a customer in Texas that had a cotton field actually adjacent to a soybean field. You know, very pertinent to the news of the day. Dicamba was sprayed over the soybean field. There was wind that day, and it showed up in the cotton farm. If you look at the cotton farm from the ground, you can tell there's damage, but as soon as we put a drone up in the sky and actually take an image over it and apply some analytics to it, that damage became even more pronounced and very identifiable, not only where it happened, but the extent of which it happened as well. You know, if we think about other specialized use cases, there's actually a farmer here in North Carolina, Brandon Batten, that also runs Flying Farmer NC. You know, he's using drones over his own operation for some of the traditional crop scouting use cases, but he's also doing things like visualizing buildings that are going to be built on a farm. So think of you want to put in grain silos on your farm, but you're not exactly sure what that's going to look like in space or where to best positionally locate it. He's flying drones over it, creating 3D models, and then from that making decisions about where building structures could go and sort of what that view will look like. You know, another use case that's more specialized that probably folks have heard about are plant counts. And we think about plant counts, sort of the traditional view is, can we use plant counts for doing, say, stand assessment of corn and make a decision about replant? And you can do it, but there are some challenges of scale there. But we're also seeing plant counts being very successful in other specialty crops. So things like tobacco here in North Carolina, or even fruit crops and permanent crops like tree crops, citrus trees in Florida, pecan trees in Georgia. And the beauty of these plant count tools, they're machine learning based plant counts, which means that these models have been trained to easily detect plants automatically and not only find them and count them, but actually size those plants as well. So there's a lot of information that a user can glean from it. So machine learning is sort of a buzzword. We hear a lot of it today, and it's kind of like, well, what is that? But really at its basis, machine learning is taking a computer, taking imagery, feeding it in, whether it be satellite, manned, from your phone for that matter, and training computer models to know what an object is. You know, to a farmer or an agronomist that's been around for years, they can look at the leaf of a plant and probably readily identify what the disease is or what the pest is or what the problem is. What machine learning is taking imagery and training computers to be able to do that in a much more efficient and a much larger scale. So machine learning really opens a lot of opportunity for being able to make efficient decisions at scale and very accurately without in an objective manner, without the subjective decisions that you might otherwise have. So, you know, another sort of emerging use case for machine learning is actually for being able to respond to damage events. So there are insurance companies out there that are using machine learning to be able to train models for detection of, say, wind damage in corn or hail damage in other crops, so that, you know, we take something that's obviously very challenging in terms of trying to walk over a field and assess exactly how much damage has occurred, and something that's very time consuming, and be able to do it in a more accurate and more efficient manner with machine learning. And so if you're thinking through, you know, what technology makes sense for me, I'll speak a little bit more specifically to drones, because that's the one that probably farmers have the most opportunity to directly be the user, if you will, themselves. When you think about drones, there's really sort of three answers you want to think about. It's, what type of platform am I going to fly? Is it going to be a multi-rotor platform, or is it going to be a fixed wing platform? And then what kind of sensor? Am I going to just use a traditional visual or RGB camera, or do I want to have multispectral data? You know, there's a lot of value in multispectral data, but frankly, a lot of information can be gleaned from just a basic RGB sensor. And then the last piece is the software, the analytics. And that covers both, how are you going to fly the drone? Are you going to fly it manually, or are you going to use an automated software that lets you plan out a mission and have the drone fly itself? And then once you has flown, the other piece of the software is, what am I going to do with that information? How am I going to process it? Am I just going to inspect the image, visually with my eyes, or am I going to run it through some sort of tool that has the analytics that we've talked about? Things that you want to consider as you're making these decisions are things like price, things like scale. You know, here in North Carolina, we have a lot of really small fields that might be only a few acres. If you're flying over hundreds of acres, a fixed wing drone makes a lot of sense because it's able to cover a lot of ground in a single flight, whereas a smaller drone maybe not. But the benefit of a smaller drone is, it's not a simple bigger is always better. There's a lot of value in the versatility of a small drone. If I have a small drone that's in the, say, $1,000 to $1,500 range, I can easily keep that under the seat of my pickup truck and have it with me at all times. Whereas if I'm flying a larger drone that might be $5,000 to $10,000 in price, it might be a little bit more challenging to take that with me or have it readily available. The flip side is the larger drones, the bigger drones, if you get into more specialized use cases, is they are more flexible in terms of being able to have different sensor types. So if we think about most of the entry-level drones, like your Phantoms or your Mavics that you would see even at, frankly, Best Buy or Walmart, there's a lot of value that can be extracted. They might look like a toy and might be used as a toy, but there's actually a lot of value you can extract from this technology. But there are some limitations. You're going to be limited to just the RGB camera that comes on there. Whereas if you have a larger drone, you can swap out and put a multispectral sensor on, or thermal sensor, some other advanced sensors depending on the use case. Another thing to consider if you are looking at fixed wings is, do you want to have sort of a traditional takeoff or vertical takeoff? Now, vertical takeoff drones that allow for you to take off in a really confined space and come back and land right where they took off. So you get some of the versatility of the multi-rotor platforms in terms of being able to take off in a small area, but still cover large amounts of ground with that drone. We mentioned software. One of the things to consider with software is really, again, what do you want to do with it? And there are sort of two main classes of software that are out there. There are local softwares, that means it's running on a tablet or a laptop that you can actually do the analytics right at the field edge. And then there's others, this cloud-based software, meaning you're going to have to put the data up to the internet. The power of the cloud is you get access to more analytics. You can do a little bit more savvy things with it and share data across with other users. The beauty of the in-field processing is you get an answer, right there at field edge before you leave. I mean, but let's be honest, there's a lot of technology out there. Most farmers today have probably seen a drone fly at this point in time, but there's still, frankly, very few of them that have figured out a way to extract value from that and say, how do I actually use this in my application versus it being just a sweet toy that I can get a nice video from? How do I step from that pretty picture, the pretty NDVI map that probably everyone's seen, to actually something that I can use in a way that's beneficial to my practice? And I really think the answer is analytics. We hear analytics a lot, but it's not just meant to be cliche, and it's not just about taking an image and doing, let's say, a health map from it. It's being targeted and having analytics that really are specific for the problems that growers have. There's a whole lot of solutions out there today looking for problems. We try to take the reverse approach and actually understand a farmer's operation, understand what their problems are, and then tailor solutions that are specific for that need. What our goal is, we do have North Carolina roots, and we want to give back, if you will, to the North Carolina industry, because we recognize a lot of technology that's been developed has really been Midwest focused. And farming's not that different here from the Midwest, but in a lot of ways it is different. So part of what we are focusing on is how do we tailor solutions that are specific to the locations we're working in. And so that, be it North Carolina and the crops that are unique to North Carolina and the climate that's unique to North Carolina, those are some of the things that we're able to work with, whether it's directly with growers, with universities, or with enterprises that are out there. We want to, again, tailor solutions that are specific to the region they're working in and the crops that they're working with. If you're a farmer and you're thinking, where do I start with remote sensing? Again, it's kind of a question that it really depends on the use case. And I really think it's important that you identify what the use case is that you're trying to solve. And that will really guide a lot of your decisions about whether it's satellite imagery or whether it's drones and what sort of analytics make the most sense, whether it's you flying yourself or whether it's someone providing that service to you. Think about what's the key takeaway. I really think with technology in general, it's about being open. I go back to, there's not a single solution that's going to solve all your problems, but be open-minded. I think a lot of people have this impression of technology that it's intimidating, it's something you don't see yourself using, but don't be scared to try it. You learn by trying it out, and you might start out with one intended use case, but completely find something different. And I actually think a lot of times we let great get in the way of good. A lot of times the low-hanging fruit, literally the bird's eye view, just being able to quickly see what's going on with our field, brings a lot of value. And until you try it and until you talk to someone that knows about it, it's hard to understand how it might could help you. So I would encourage you to be open to new technology and get in touch with someone, whether it's an extension agent, whether it's us at spadeGEO. There are folks out there that'll be glad to help you answer your questions and figure out what the best solution is for where you are with technology today. So if you'd like to get in touch with us, you're welcome to go to our website, which is just spadeGEO.com, or you can email us at info@spadeGEO.com.